Okay, page 170, number 1. We've solved this one once, assuming that we were memorizing the formula for the derivative of the arc cosine. Let's do it without that assumption. If we don't have it memorized, how do we go about solving this? We're going to use implicit differentiation. And so here's our original equation. Y equals the inverse cosine of x squared. Well, if that's true, then that's the same thing as saying x squared equals the cosine of y. And so let's use implicit differentiation on this. The derivative of x squared is 2x. The derivative of the cosine of y is negative sine of y, but we're taking the derivative with respect to x, so it's a chain rule, because that's not an x, it's a function of x. So we need to multiply by the derivative of y, dy dx. And now, before we go any further, let's think about what x and y are. If it's x squared equals the cosine of y, y is an angle. So here's a picture that kind of shows what's going on. Y is the angle. Cosine of y is supposed to be x squared. Cosine is adjacent over hypotenuse. So adjacent divided by hypotenuse has to equal x squared. We could do all kinds of things, but the easiest thing is to say adjacent equals x squared and hypotenuse equals 1. Then the opposite side here, according to the Pythagorean theorem, has to be 1 minus x squared squared, so x to the 4th, square root of that. Square root of 1 minus x to the 4th is what that side has to be. And now, right here in the derivative, we're looking for the sine of y. So the sine of y would be opposite over hypotenuse. It's going to be this square root divided by 1. And that changes this equation into 2x equals negative square root of 1 minus x to the 4th dy dx. Solve that for dy dx and we're done. Negative 2x divided by the square root of 1 minus x to the 4th. There's our answer.